we are doing square roots and radicals, and there are two properties that you need to make sure of when you're doing these, okay? Will you take those off? The first one is this. If you are multiplying under a radical, a times b, that's the same as if you break them up and do the square root of a times the square root of b. So you may separate those, and it's the same thing, okay? Same thing goes for division. If there is division under a radical, so a divided by b, and we're taking the square root of that whole thing, that's the same as saying the square root of a divided by the square root of b. So we're just kind of rearranging where the radicals lie, but they are equal, okay? Simplest radical form. So from here on out in this chapter, everything needs to be in simplest radical form always. Simplest radical form means these three things, okay? So no radicands have perfect square factors except for one. So you cannot have any of these factors as part of your new ending number, okay? And I'll show you what I mean by that as we do it. You can't have a radicand. So radicand is what's under your radical, right? That has a fraction. And then no radicals appear in the denominator. So you cannot have a fraction where your denominator has a radical in it. That's not considered simplest radical form. So all of this, to say these, we're just going to kind of plow through these, and stop me if I go too fast or if I lose you on something, but this should be familiar. You have done it before. All right, simplest radical form. So we are looking for, is there a perfect square that goes into 50 that we could factor out of the square root of 50? 25, okay? So this is the way I set it up. This does not need to be the way you set it up, but this is just what helps me visualize the simpler version of it. I do it like this. I break it into the square root of 25 and the square root of 2, right? Because we said you can take the square root of 25 times the square root of 2, or 25 times 2 is 50, and square root it, and they're the same thing. What is the square root of 25? 5. The square root of 2, you cannot do anything with. So your answer, simplest radical form here, is 5 rad 2. Okay? Questions on that? All right, 5 rad 12. Is there a perfect square that we can divide 12 by? 4. So I always put the perfect square first, because that's the one that's going to become a whole number, and then the one that's not a perfect square second, because that's what's always going to be at the end of your answer. Don't forget about this guy here. If you want to just carry him down with you, that's fine. What is the square root of 4? 2. So you're saying 5. What operation is happening between the 5 and the rad 4? Multiplication. So you're going 5 times 2 times rad 3, which is 10 rad 3. Okay, so that would be simplest radical form. How about this one? What perfect square is 700x divisible by? 100, right? So if I break this down, the perfect square is 100. The one that is not a perfect square, what are we left with? Not 7. 7x, right? So this is going to become 10 times the square root of 7x. 10 times the square root of 7x, or 10 rad 7x, is the same thing. Okay? Rad, radical, square root, same thing. So far, so good? Not radical? I love it. I think it is radical. Okay, this one. You have a square root that covers up, that has a fraction in it. Not allowed. So we need to rationalize it. We need to get it out of there. The way that we're going to do that is, first we're going to think of this as the square root of 2 over the square root of 3. Okay? And the way you get a radical out of the denominator is you multiply it by itself, because what is the square root of 3 times the square root of 3? It's 3, okay? But here's the thing. If you multiply by the square root of 3, or 1 over the square root of 3, you're changing your value, and we can't change our value. What number can you multiply that does not change the value of your whatever you have? 1. So we need to multiply by 1 using rad 3. How do you do that? Rad 3 over rad 3. So if I multiply by rad 3 over rad 3, it's not changing the value, right? So what's on top? Rad 6. 2 times 3 is 6. And then rad 3 times rad 3 is the square root of 9, which is 3. Okay? So that would be rad 6 over 3. Yeah?
Did you multiply that by rad 2 over 5?
No, because if you multiplied by rad 2 over rad 2, you're saying multiply this by rad 2 over rad 2? If we multiply rad 3 by rad 2, we get rad 6, which is still a radical in the denominator. We're trying to get the radical out of there. So you multiply by itself, rad 3 times rad 3 is 3. Does that make sense? Yes? No? Okay, so he's saying square root of 2 over square root of 3. You cannot have a radical in your denominator. He's saying, could you multiply by rad 2 over rad 2 and get it out of there? Well, if we did this, rad 2 over rad 2 is 4, but rad 3 times rad 2 is rad 4, which is 2. You still have a radical in the denominator, which is not allowed. That's not simplest form. So you can't do that. Now, does that make sense? Yes. If you just watch as we go, you'll get those concepts. Just stick with me. Okay, so this you can rethink of as rad 5 over rad 12, okay? But you can't have a radical in the denominator. Now, here's the deal with this one. Technically, right now, you could do it 2 different ways. What's one way I could do this right now? So you can multiply by rad 12 over rad 12. Okay, that would be one way to do it. Or you can simplify the rad 12 first and simplify from there then. So if you wanted to do it that way, this would be rad 5. What's rad 12 simplified? 2 rad 3, right? Rad 12 is 2 rad 3. So you could call this rad 5 over 2 rad 3. And then what would you multiply that way? So these are the same thing, right? I'm just saying here are your 2 options. We could multiply this by rad 3 over rad 3. Okay? Let me show you the difference in what you get with these. On top here, I would get rad 60. On bottom, I would get 12, right? Rad 60 is not in its simplest form. So if I simplify this, rad 60 is rad 4 times rad 15, or 2 rad 15, over 12. Is that simplest form? No, 2 over 12 would reduce to rad 15 over, so divide by 2 on both of these, rad 15 over 6. Okay, so we could have gotten there that way, or if you look at this bottom one, rad 5 times rad 3 is rad 15. 2 times rad 3 times rad 3 is 2 times 3, which is 6. Okay, so I recommend you simplify first because it just is simpler in the whole process, but you don't have to. You could do this right off the bat and you'll get there. You just need to keep simplifying. Does that make sense? Yes? I'm happy to go back to any of these if we need to renege. All right, number 7, what would you do? You would multiply by rad 2 over rad 2, right? Multiply by 1 so it doesn't change our value. So on top, you have 6 rad 2. On bottom, you have what? 2. Okay, simplify that. 6 over 2 is 3 rad 2. So your answer would be 3 rad 2. Okay? Yeah.
Why did we have to multiply by the rad 2 instead of?
Rad 2 over 2. Why did we have to do this?
Yeah.
Because you have a radical in the denominator and that's not allowed. So how we get it out is we multiply by 1, but using that radical, right? So I'm just multiplying by 1, rad 2 over rad 2. So when I multiply that, rad 2 times rad 2 is rad 4, and rad 4 is 2. So now I have a whole number instead of a radical in my denominator. Good? Okay. If you multiply a radical by itself, you will always get the number under the radical, right? If I go rad 4 times rad 4, think about what that is. That's rad 16. What's the square root of 16? 4, right? So when you multiply a radical by itself, you will always get the number under that radical. Does that make sense? Like if I go rad 3 times rad 3, 3 times 3 is 9. So that's the square root of 9. And the square root of 9 is 3.
So that's how you tell if they're a radical?
What do you mean how you tell if they're radical? Like if they have the square root over top of them, it's a radical number. Is that what you're asking me?
Yeah, but is there a time when it doesn't have the square root over it? And then we have to figure out if that's a radical or not?
No, if there's no square root over it, it's not a radical number. So it's just if you see the square root, you have a square root, you have a radical. Yeah. Does that make sense?
Yeah.
I don't know what you're asking if I'm answering your question.
My question was basically just how can you tell a number's okay?
If it has the square root over it. Yeah. Okay, look at these two problems. Number 7 looked like this, 6 over the square root of 2. Number 8 is the square root of 6 over the square root of 2. If you think back to our rule here, this can be this. So essentially what they're saying with this one is we could think of this as the square root of 3 over 2. 6 over 2. Sorry, I'm doing math in my head. What is 6 over 2? 3. So you're allowed to divide these if they're both radicals. If they're not both radicals, you can't divide them. But if they're both radicals, like they are here, we can divide. 6 divided by 2 is 3. Okay, so the square root of 6 divided by the square root of 2 is the square root of 3. And now you no longer have a denominator that's a radical, so you're done. Okay, so like if I said the square root of 10 over the square root of 2, because they're both radicals, I can divide those. So what is that? The square root of 5, rad 5. Okay?
So when they're both radicals, then
If they're both radicals, you can divide, and if that gets rid of your radical in your denominator, then you're done. Okay?
well, that's fine.
Yeah.
But you can only, okay, I do it the long way. If you do it,
You could do times rad 2 over rad 2, and then eventually you'll simplify, and it will still come to, oops, that. Oh, I skipped one. Sorry, guys. Let's go back to this guy. My bad. Number 6. Number 6 here, if you break this up, the square root of 3 over the square root of 4, what is that? What's the square root of 4? 2. So this is the square root of 3 over 2. Those are not the same anymore. One's a radical, one's not. You can't divide it, so that's just your answer. All right, now number 9. Tell me what you would do.
Do it times 3 and then you cross out 3 because they.
Not times 3.
so number 6 is 2
Rad 3 over rad 3, right?
Number 6 is 2 rad 3.
Number 6 is rad 3 divided by 2. Okay, so you multiply this by rad 3 over rad 3. What do you get on top? 3 rad 21. You can multiply those because they're both radicals. You cannot multiply that, okay? So this would be 3 rad 21 over what? Over 3. What is that? Rad 21. 3 divided by 3 is 1. So you just get rad, 21. There is no perfect square that goes into 21, so you're just done. God bless you.
Bless you.
Okay? All right. Number 10. So this one gets a little fancy now because now you have an operation in between things on your numerator. Allure. You're going to want to know how to do this. You're going to use it a lot in a lot of the lessons to come. So wake up and stay with me. What do you think you should do first here? We're not going to divide by 2 because you'd have to divide both of those things by 2. So I guess technically you could do this, 4 over 2 plus the square root of 20 over 2. You could do that and simplify it from there. Sure, you could do that. I'm not going to do that. What's the square root of 20 simplified? The square root of 4 and the square root of 5, so that would be 2 rad 5, right? So here's what you have. 4 plus 2 rad 5 over 2, okay? Now, if you're dividing the whole thing by 2, you have to divide both terms by 2. So 4 divided by 2 is 2. 2 rad 5 divided by 2, technically it's this whole thing, but this is all that reduces. 2 rad 5 divided by 2 is what? Did I lose you?
Circles.
Sorry, take the circles away. Okay, 4 over 2 is 2, plus 2 rad 2 divided by 2 is just rad 5, right? 2 divided by 2 is 1, so it'd be 2 plus rad 5. Now we don't have a denominator anymore, so that can be your answer. You can't add them, right, because one's a radical and one is not. So it's just got to stay 2 plus rad 5.
Would it be wrong if I were to take away the plus sign?
Yes.
Okay, cool.
Yeah, because you're adding, not multiplying. If you take it away, you'd be multiplying, right? All right, this one. Square root of 18. We can simplify that. What do you simplify it to? 9 and 2. So it's 6 minus, this is 3 rad 2 over 6. Okay? If we break that up, basically what we're saying is 6 over 6 minus 3 rad 2 over 6. Right? We're doing this and this because you have to divide by 6 on both parts. Okay? What's 6 over 6? 1. Minus, what's 3 rad 2 over 6?
Just that.
1 rad 2 over 2, which we can just write as rad 2 over 2. So this just divide by 3, you get 1 and 2. So rad 2 over 2. So this is as simple as we can go. Okay? Number 12. How we doing? Pretty good. Okay, so rad 12, eventually you're going to get so used to seeing these numbers that you're just going to remember what it is. Anyone remember what rad 12 is off the top of your head? It's 4 and 3, but it's 2 rad 3, right? So it's negative 6 plus 2 rad 3 over 4. You need to divide both parts by 4. So negative 6 over 4, you can call that just negative 3 over 2, because you always want to reduce as much as you can. Plus, now this part of it, what does that become? Rad 3 over 2. So that is your answer. Or, even simpler yet, I would write it negative 3 plus rad 3 all over 2, because you're dividing by 2 on both of them. So technically, this is the best answer.
What would that top
I would probably let you take that as full credit. Okay. 13. When you multiply that, you can actually multiply because they're both radicals. So what does that become? You're multiplying. 28, right? Okay, but now here's the deal. That's not simplest radical form.
2 rad 7.
Break it down. The square root of 4 times the square root of 7 is 2 rad 7. That is simplest radical form. Okay, 14. You're squaring 3 rad 5. So you kind of need to think of this like distributive property a little bit. This is 3 squared times the square root of 5 squared, right? You're squaring both parts of it. What's 3 squared? 9. What's the square root of 5 squared? 5. So your answer is 45, right? The square root and squared, they cancel each other out. So just 45. See that? You should pay attention. Okay, what'd you say? So this is rad 2 times 7 rad 8. What can be multiplied in that? The radicals, right. Rad 2 times rad 8 is rad 16, and we are multiplying that by 7. What's rad 16? 4. So you're doing 7 times 4, or 28. Okay? Moving right along. Who said my name?
Oh, so we multiplied the rad 2 and the rad 8 together with the 7 else?
Yeah, because the 7 is not a radical, right? It's not under the radical symbol at all. So you can't multiply it by what is under a radical symbol. Okay? All right. Square root of 100a squared. 10a. You guys are good. So it's the square root of 100 is 10. Square root of a squared is a. Remember when you square a variable like that with an exponent, you're just cutting the exponent in half. So if it's a to the 4th and you square root it, it's a squared. If it's a to the 12th and you square root it, it's what? A to the 6th. Okay? Okay. This one. So here's what I would do first on this. X to the 3rd over x is really what? X squared, right? When you're dividing exponents, you're subtracting. Do you remember that? So the simpler way to do this is to just set your problem up. X to the 3rd divided by x is x squared. That's a numerator, okay? So it's 2x squared over 3 is an easier way to look at it, okay? So you can think of that as the square root of 2x squared over the square root of 3. We're going to multiply by what? Rad 3 over rad 3. So on top right now, you have the square root of 2 times 3 is 6, x squared, over 3. What is the square root of x squared? X. So that x is going to come out of the radical because we square rooted it. So we have the square root of 6 still under the radical. We have a 3 on bottom. There's nothing there that you can simplify. So that would be your answer. How we doing so far? You still with me? Don't check out. Don't check out. Stay with me. Don't what? Yes, we have one left. Push through. Power through. Okay. This one, there's a couple ways you could do this one.
What's the easiest option?
Trying to figure out why I did it that way as one of my options.
Can you 4 the 2
Huh.
and then square root the both?
For the 2.
Well, because I didn't cube, I didn't know what was ahead.
2 to the 4th power. Can you 2 to the 4th power both. Yeah, you can. So 2 to the 4th power is what? 16. So you could do 16 over 50 and square root both. So the square root, I'm trying to think if this was the easier option. Not really. You could square root both right now. I would say the better way to do it is think of it like this. 16 and 50, you can reduce that fraction to what?
8 or
Right. So I would call this the square root of 8 over the square root of 25, because then you have a perfect square on the bottom. But you don't have to. You could do, like, if you wanted to do times the square root of 50, ooh, that's ugly. Or break it into simplest radical right there. But I would go from here. So from here, you have square root of 8 would be the square root of 4 times the square root of 2, right? So that's 2 rad 2 on top. What's the bottom? 5. And there's nothing you can reduce there, so that would be your answer.
Mr. Rubin,
Still trying to figure out what I did on that one, but yeah.
If we ever get like 2 rad 2 over 5 rad 2, rad 2 is
Right, if you have 2 rad 2 over 5 rad 2 divided by rad 2, any number divided by itself is always what? 1. So these would go away, and you would have 2 over 5.
awesome. And that would be your answer.
And that would be your answer. That's not your answer for this one, but if that's the scenario, that would be your answer.
Okay.
Yeah.
Is that okay?
What he just said?
Yeah.
I mean, any of it can be. It's all simplifying radicals, right? Okay, so your back side, there are 18 questions there. Hopefully they go fairly quickly for you. Look for perfect squares, right? Don't leave any radicals in the denominator. You got this.